Hello students, so we came here again with this new topic which is a previous year practice question for electric charges and heat for the class 12th in physics 2023-24 exam. So let's begin with this objective type questions or practice set 1. The first question we have a body of a charge 9.6 10 to the power minus 20 coulomb. It is possible, not possible, may or may not be possible, that are not sufficient. So, the correct answer for this question is not possible. Let's see the solution for that. So, we know that Q is equals to NE. We have N is equals to Q by E. If I am just taking the body charge 9.6 10 to the power minus 20, and E, which is the 1.6 10 to the power minus 19. So the answer will come N is equals to 96 by 16 into 10 to the power minus 1. So 960 or 96 divided by 160 is a rational number or fraction number. It came as a fractional digit. But we know that N it is an integer. So this not be possible. Moving ahead with this next question. A body has a charge of 6.4 10 to the power minus 19 coulomb. Is it possible? Not possible. May or may not be possible. Data not sufficient. The correct answer for this is possible. Let us see the solution of this question. So Q is equals to NE and we know this will be satisfied. How this will be satisfied? We know N is equals to Q by E. So if I'm just Q is given 6.4 10 to the power minus 19 and the value of E we know 1.6 10 to the power minus 19. If we divide this term, so we get the number of N. So the value of N we came, that is a 4, which is an integer. That's why this will be satisfied. Hope you understand the solution. Moving ahead with this next question. So next question we have, when the number of electrons to be removed from a glass rod in order that it acquires a charge of 1 microcoulomb is 6.25 10 to the power 12, 10 to the power 12, 6.25 10 to the power 13, 10 to the power 30. So I think you solve this particular problem and you get the answer. The correct answer for this question is option 1. So let's solve this particular problem. So here the solution is Q is equals to NE. We know the Q is given 10 to the power minus 6 because 1 microcoulomb is given there. So the value of 1 micro means 10 to the power minus 6 coulomb. We just put this value and we get the data, which is 6.25 10 to the power 12. Moving ahead with this next question. Two unlike charges attract each other with a force of 10 Newton if the distance between them is double the force between them is. So let's solve this particular problem. We have an option 40 Newton, 20 Newton, 5 Newton, 2.5 Newton. Hope you already done. Let's see the solution. So we know that force is inversely proportional to the square of distance between them. So F1 by F2 is equals to R2 by R1 whole square. F2 is equals to F1 by 4. That means the value of F2 came 2.5 Newton and the correct option is a 4. Moving ahead with the next question. A charge Q is divided into two equal parts Q1 and Q2 such that they experience maximum force of repulsion when separated by a certain distance. The ratio of Q, Q1 and Q2 is. So we have an option 1:1:2, 1:2:2, 2:2:1, 2:1:1. Now let us see the solution of this question. Q1 is equals to Q2 is equals to Q by 2. Hence, the correct option is the fourth one. Next, we have a question. 2 point charges of 2 microcoulomb and 6 microcoulomb, both are positive, repel each other with a force of a 12 Newton. If a charge of minus 4 microcoulomb is given to each of these charge, what will the force will be now? We have option 0, 4 Newton attractive, 8 Newton repulsive and 4 Newton repulsive. So, the solution for this question is F is equals to KQ1 Q2 as we know by R square. So, we can say F is directly proportional to the Q1 Q2. According to that, the correct option is a 4 Newton. For more elaboration, I just want to explain here. Like force is directly proportional to the Q1 Q2. So, if I am just adding these two charges by a minus 4 coulomb. So, Q1 will be plus 2 microcoulomb and plus minus 4 microcoulomb. This will be converted itself into minus 2 microcoulomb. And then Q2 will be equals to plus 6 microcoulomb plus of minus 4 microcoulomb. That means this will becomes again plus 2 microcoulomb. So initially if we just take, so this will be 12 and after that if we just take, so this will be minus 4. F will be minus 4 came here with the microcoulomb. Okay, or something, so we will say that F is directly proportional to the minus 4. Minus showing for the attraction. Okay. And 4 showing the magnitude. So this will be the 4 times of a attractive force. We can calculate from here. Next we have the force between two charges placed in a air at a distance r apart is the force, then the force between the same two charges if the dielectric having K is equals to 4 and thickness r by 2 is introduced between the charges. Let us see the solution for this question. So we know that force is inversely proportional to the square of the distance between them and F2 is equals to if the dielectric having inserted, so the formula will be this. I'm just putting the value of a K. So F2 is equals to 1 by R square times 4 divided by 9. So F2 will be 4 by 9 times F1. According to that, the first option is the correct. Hope you understand the solution. The next question we have a force of 4 Newton is acting between two charges in air. If the space between them is completely filled with glass, epsilon r, which is a relative permeability, is equals to 8, then the new force will be, we have right now options are 2 Newton, 5 Newton, 0.2 Newton, 0.5 Newton. So let us see the solution for this question. We have a F prime is equals to F by K. F prime is equals to 4 by 8 because the value of 4 is given. Force is given which is 4 Newton. The K is given 8 Newton. That means the change in the force is 0.5 Newton. 2 units negative charges are placed on a straight line. A positive charge Q is placed exactly at the midpoint between these three charges. If the system of these three charges is in equilibrium, the value of Q is. Let us see the solution of this question. So Q is equals to plus Q naught by 4. That 1 by 4 times is comes 0.25 according to that. The fourth option is the right one answer. Next, we have two charges of 200 microcoulomb and minus 200 microcoulomb are placed at the corner B and C of an equilateral triangle ABC of a side 0.1 meter. The force on a charge of 5 microcoulomb placed at a. So these are the options. Let us see the solution for this question. So firstly, we will make the diagram for this. The diagram is we have a 200 microcoulomb of charges. Because of that, the force line will be making 120 angle. Okay. So I'm just putting all the charges. So F is equals to theta will be 120. Put this value and we will get Fr, that means relative force, that will be 1 by 4 pi epsilon naught Q1 Q2 by RL square. So let us see that how the answer 4 came. So here we have a F is equals to 1 by 4 pi epsilon naught. So the value of this will be this. Q is given 200 microcoulomb 10 to the power minus 6. The value of Q2 is 5 10 to the power minus 6 divided by the distance between them, which is a 10 to the power minus 2. After solution, we will get this value 920 into 5. After solution, the value we will get F net is equals to 900 Newton, which is the answer key 4. Hope you understand the complete solution. Moving ahead with the next question. A charge Q is placed exactly the midway between two charge Q and Q, separated by a distance 2r. Q and minus Q are there. 2r in air. The forces on the charge Q is. Let us see the solution of this question. So F is equals to 2F. Because of the separation of the distance will be changed. So now 1 by 4 pi epsilon naught QQ by R square is the formula. When we just solve this formula, we will get the option first. Next question, we have an alpha particle and beta particle are projected into the same electric field. The ratio of the forces on them is 2:1, 1:2, 2:3 and 3:2. Let us see the solution of this question. F is directly proportional to the Q. Regarding that, the correct option is 1. A charge of 4 microcoulomb is placed in a uniform electric field intensity 100 Newton per coulomb. The force acting on the charge is. The correct answer for this question is in the solution. So, the solution we have F is equals to QE. The value of putting of Q and E. According to that, the second option is the right answer. 14th question, we have a field due to a charge at a distance x from it is E. When the distance is a double, the intensity of the field is. So, see the solution of this question. So, E is directly proportional to the 1 by R square. E1 by E2 is equals to R2 square by R1 square. E1 by E2 is equals to 4. So, E2 is equals to E by 4. According to that, the correct option is a 4. The electric field due to a charge at a distance of a 3 meter from it is a 500 Newton per coulomb. The magnitude of a charge is. So we have a solution. Let us see. E is equals to 1 by 4 pi epsilon naught Q by R square. I am putting all these values and we get the result, which is 0.5 microcoulomb. Next question, we have two charges of 5 microcoulomb and 100 microcoulomb are separated by a distance of 0.6 meter The intensity of an electric field at a point midway between them. So we have an option. Let us see the solution of this question. E is equals to 1 by 4 pi epsilon naught q1 divided by r divided by 2 whole square minus q2 r by 2 whole square. According to that, the second option is the correct. What you have to do is just put this value and you will get the result. Three small spheres, each carrying a positive charge q, are placed on the circumference of the circle of radius r to the form of equilateral triangle. The electric field at the center of the circle is. So we have seen the solution. E net is equals to 0 because this will be at the center of the circle. So at the center of the circle there will be no charges, because of that electric field will be 0. According to that, the correct option is a 4. Next we have a mass m carrying a charge q is suspended from a string and placed in a uniform horizontal electric field intensity E. The angle made by the string with the vertical in the equilibrium position. Let us see the solution of this question. So we have a particular bob which is suspended by a string by the help of a knot. Mix an angle theta with the normal, and the charge q is here. So because of electric field, they will experience a force which is F is equals to QE. So if the electric field is applied on this body, so tan theta will be QE by mg. According to that, if we just calculate the value of a theta, so this will be tan inverse QE divided by mg. Next question we have an electron is placed at the center of a sphere of a radius 0.2 meter having a charge 5 × 10 to the power minus 2 coulomb. The force on the electron is 0, 11 × 10 to the power 9, 22.5 × 10 to the power 9, 2.5 × 10 to the power 9. The answer we have, electric field we know at the center is 0 for a spherical charged shell. So the answer will be 0. The question we have, an infinite number of charges, each of a magnitude q, are placed on the x-axis at a distance 1, 2, 4, 8 meters from the origin. The intensity E of the electric field at the origin is. So as we see the solution already, E is equals to 4 pi epsilon naught. The number is given in the GP form, and after solution we will get the option A. Next we have a question. A particle of mass m carrying a charge q is placed in a vertical electric field so that it is suspended in air in equilibrium against gravity. The intensity of electric field is q divided by mg, qg by m, mg by q, and mg by g, mq by g. So we have a solution. mg is equals to qa. I just want to explain more over there. If we have a particle which is carrying a charge q and the electric field will be vertical. So I'm supposing this will be the electric field which will be the vertical direction. Clear? And gravity, as you can see, against applies on it. So this will be mg, and the force because of this electric field is applied on the upward direction, which is a QE. So they both will be balance each other. That's why mg is equals to QE came here. So E is equals to mg by Q according to the third option is the correct one answer. Now two electric charges of a 10 to the power minus 9 coulomb and minus 10 to the power minus 9 coulomb are placed at the corner AB and the equilateral triangle ABC of a side 5 cm, the electric intensity at C is. So, let us see the solution of this question. We have a triangle which makes an angle 120 from the external side. The charges are given. So, the electric field will be 1 by 4 by epsilon naught q by L square. If we just put this value, we will get the result of the E, which is the option second. Next question we have a proton and a deuteron are sent into an electric field. The ratio of acceleration of proton and deuteron is. We have an option 2:1, 1:2, 1:1 and 4:1. The solution we have A is equals to QE by M. See how this solution came. We know that the value of F is equals to MA and the value of F is equals to QA. This is for electric field in the presence of electric field, and this force is applied as in if the body feels acceleration, if the particle feel acceleration. So, if we just taken from the equation 1, substance from the equation number 1 and 2, then we can say that this is a 2 and this is a 1. So, we can say that from first and second, MA is equals to QE. MA is equals to QE. And from here, if I'm just putting the value of A, so this will be QE divided by MK. That means A is inversely proportional to the M. That's why the ratio will be 2:1. Next question we have, in a region where intensity of electric field is 5 Newton per coulomb, 40 lines of electric force are crossing per square meter. The number of lines crossing per square meter where intensity of electric field is 10 Newton per coulomb will be. Let us see the solution of this question. Number of field lines is directly proportional to the electric field. N1 by N2 is equals to E1 by E2. That means 40 by N2 is equals to 5 by 10. And the answer will be 18. Next we have a charge Q is placed at the mouth of a conical flask. The flux of the electric field through the flask is. Hope you mark the solution on the right answer. Let us see the solution. So half of the flux passing through the cone, that means phi is equals to Q by 2 epsilon naught. According to that, the correct option is the 3 one. At the corner or the center of the cubical box, which is containing the charge positive Q, is placed. The value of the total flux that coming out of the each surface is. I hope you mark the correct option. Let us see the solution. Sigma is equals to Q by A we know, and the value of A for the cubical box is a 4 pi r square. Now we just put this value and get the result, which is a Q by 6 epsilon naught. Last question we have a charge Q microcoulomb is placed at the center of a cube. The flux coming out from any surface will be. Hope you marked the correct answer or option. Let us see for more clearance the solutions. So we know that Q is equals to 1 by 6 Q by epsilon naught for the flux when the particular charge is placed at the center, because all the flux, all the field lines are passing from all the surfaces can pass. So for more elaboration, I just want to explain it more. If this will be a cube, so the cube have 6 faces, and for all 6 faces we know the phi will be q by epsilon naught. Okay. If the charge is placed at the center, that means the field lines or the electric field lines or the flux can pass all the 6 phases. So for the 6 phases, the field lines will be 6 phi divided by epsilon naught, and for the phi, this will be q by 6 epsilon naught. According to that, the correct option is first one. So thank you for this precious video content. Hope you like it. Wait for the next video. Till that, take care everyone.